All right, so we're going to prove that a trapezoid is isosceles if and only if its diagonals are congruent. Let's start this proof. Since this is an if and only if, we'll start with P implies Q. So we're going to assume AB, CD is an isosceles trapezoid, right? And this implies that AB is congruent to CD, right? AB is congruent to DC or CD, right? And we also proved in the last theorem that these base angles are congruent. And angle A is congruent to angle D. Now we're going to draw diagonals BD and CA, right? So let's go ahead and draw those diagonals, try to get them as straight as possible. Good, okay. So we drew those diagonals. Now we're going to consider, consider triangle ABD and triangle CAD, right? Okay. So as you can see, AB is congruent to CD, right? So AB, let's move this down a little bit. Scoot it up a little bit. There we go. AB is congruent to DC, right? We have that angle A is congruent to angle D, right, in both those triangles. And we have AD congruent to AD. So AD, let me move that down. AD is congruent to AD. So these three things together imply, by side angle side, that triangle ABD is in fact congruent to triangle CAD. And as we can see, the corresponding sides BD and CA would be congruent if these two triangles are congruent, right? So that means that BD is congruent to CA. Right? And now we're done with the P implies Q because BD is the diagonal and CA is the diagonal, and we proved the diagonals are congruent, right? Now we're going to go the other way with Q implies P. So I set it up another one. So now we're going to do Q implies P. All right. So we've got to assume the diagonals are congruent. So let's draw those diagonals again. Okay. So we're going to say that BD is congruent to CA. Okay. Now we're going to draw altitudes. And of course, we know this is a trapezoid, right? We just don't know. We want to prove that it's isosceles. Draw altitudes, BE, and CF. So let's get those straight lines, or as straight as I can get it. There we go. All right, let's draw those altitudes. Okay. Okay, so BE and CF, right? Okay, so let's scoot down a little bit. So now we're going to consider, so we know, let me mark up a little bit. So I know that this one here is congruent to this one here, right? Let's see, drawing. Oh, we also know that BC is parallel to AD, right? So let me get out of this. So A, B, C, D is a trapezoid, right? Implies that BC is parallel to AD, right? And we know that this and this are 180, so that means these must be parallel, right? So the measure of angle BEF plus the measure of angle CFE is equal to 180. So that implies that BE is parallel to CF. Now, of course, we have BC is parallel to EF and BE is parallel to CF. That means BCEF is a parallelogram, right? So these two things together, so let me write that. So BC parallel to AD. Well, I guess ADEF, right? Because EF is a part of AD. EF and BE parallel to CF implies that BCFE, right? BCFE is a parallelogram. Okay. All right. So if it's a parallelogram, that means BE, opposite sides of a parallelogram are congruent. So that means BE is congruent to CF, right? So this, let me go down a little bit. This implies that BE is congruent to CF. Okay, so now let us see. Oh yeah, we have hypotenuse leg, right? BE is congruent to CF. If we look at triangles of BED and CFA, we have leg congruent to leg, hypotenuse congruent to hypotenuse. There we go. So let's consider triangle BED. And triangle, so BED and CFA. Okay, so hypotenuse congruent to hypotenuse, so BD is congruent to CA. We have leg congruent to leg, BE congruent to CF. And, of course, we need to BED, measure of angle BED is equal to 90, which equals the measure of angle BED CFA, right? CFA. So these three things together imply by hypotenuse leg that a triangle BED, BED, right? BED is congruent to triangle CFA. And let's see, if these two triangles are congruent, that means AF is congruent to DE, right? This implies that ED is congruent to FA, right? ED is congruent to FA. And let's look at ED, right? This implies, so ED is equal to EF plus FD, right? EF plus FD is equal to, and FA is just F or EF plus FA, right? EF plus, wait, yeah, EF plus EA, right? So the ES we can subtract on both sides, so that gives us FD is equal to EA. So of course that means they are congruent. Okay, so now we have this is congruent to this. And now we have BEA is congruent to CFA by side, angle, side, right? So let's consider triangle BEA and triangle CFD. So now I have BE is congruent to CF. I have angle BEA, angle BEA is congruent to angle BEA CFD, right? And I have AE congruent to FD, or EA congruent to FD. So these three things together imply by side, angle, side that triangle BEA is congruent to triangle CFD. And if these two triangles are congruent, that means AB is congruent to CD. Right? And if this is a trapezoid where, AB is congruent to CD, right? So let me put that here. AB is congruent to CD. That means we're dealing with an isosceles trapezoid and we're done. So this implies that ABCD is an isosceles trapezoid. And that is the proof.